So we'll start on page 207, and let's just start towards the beginning. I'm not caring about 1 and 2, but let's just look at number 3. And number 3, we're supposed to identify what quadrant this would be in. So we have pi over 16.
Would it be on the top? It would be on the first or second one because it's positive.
Okay, it's positive, but that doesn't matter.
It
This is the actual angle.
would be quadrant 1.
So we're going to look at pi over 16. That's a pretty small number, right? It's definitely less than 1/2.
Well, you can't
So it's
split-
going to be in the first quadrant.
Yeah, it would be.
Okay?
Let's say you can't see it.
So let's jump to number 5. Negative 9 pi over 15. Okay, this one's a little bit tougher, right? So it's in the negative direction, and it's going to be somewhere in 3 or 4 because 9 over 15 is less than 1. And so now we have to figure out, is it more or less than 1/2?
More than 1/2.
It's more than 1/2, right? Because half of 15 is 7.5. So it's probably going to be somewhere like here. So that would be the third quadrant. If we jump ahead to number 8, we have 13 pi over 8, and we're supposed to find 18, sorry. We're supposed to find the supplement and the complement. So supplement adds up to 180 degrees, but if we're in radians, it adds up to pi. So basically, I need 13 pi over 8 plus some number to add up to pi. I'm going to get a common denominator right away for pi. So then I can subtract 13 pi over 18. So then x equals 5 pi over 18. So that was supplement.
Wait, why do you have to?
Now there's not going to be a complement because 13 pi over 18 is already bigger than 90 degrees, or pi over 2, right? It's already bigger than half. So there is not going to be a complement on this one. Now if I jump ahead to, let's say, 18, oops, 18 is 49 degrees. So if I want to find the supplement, it has to add up to another number to give me 180 degrees. And this should be pretty simple math, right? We subtract 49 from both sides. Okay, so then, oh, you're not going to let me. So then x equals 131, I think. For the complement, it has to add up to 90 degrees. So we subtract 49, and x equals 41 degrees. All right, so if we turn to page 208 now, this one, if we start with number 42, number 42 says they give us this angle 3 pi over 4, and we're supposed to figure out what are the coordinates on the unit circle at that spot. So 3 pi over 4 is here, so what are the coordinates right there? What's the x value? Well, that's going to be negative root 2 over 2, and the y value is going to be a positive root 2 over 2. Right, using our unit circle and those points on the unit circle. If I look at 44, they gave us negative 4 pi over 3. So now we have to count backwards, right? 4 pi over 3 is negative. We're going to go this way. That is the same as 2 pi over 3. Correct? So now I'm trying to figure out what is that angle there, or what are the coordinates there. So x is short here, that's going to be a negative 1/2. Y is long, that'll be root 3 over 2.
I just get kind of confused when you're trying to figure out the short, like just
Yeah,
remembering
so do
that.
I think that's right.
Okay, so if you draw the triangle though, do you see the short side and the long side?
Yeah.
Okay, so then it's just 1 is smaller than 3, isn't it? So the short side is going to go with the 1/2. The long side is going to go with the root 3 halves. Okay, I don't know how else to get you to remember that. Mm-hmm.
How do you just know that?
46 we're supposed to find the trig functions of an angle. This one says pi over 4. So the first job is to identify where your angle is, right? Pi over 4. Identify your x and y values. I like pi over 4 because they're already root 2 over 2, root 2 over 2. And then we start filling this out. So we've got sine of pi over 4. And yes, you have to put pi over 4 there, people. Do not just write sine. Pi over 4 is needed. Okay, sine is the y value, and the y value happens to be root 2 over 2.
So how do you remember that?
Psi y.
Yep, sine and y rhyme.
Okay.
Say psi y.
Pi
So
y.
you just learned something.
Yep, something. Cosine of pi over 4 is the x value, so root 2 over 2. Tangent of pi over 4 is the y value over the x value, which is just going to be 1, right? Because it's the same thing. Y and x are the same thing. Okay, cosecant is the reciprocal. So this is the fun part, right? Because it's going to be 2 over root 2. And I have to rationalize, so I multiply top and bottom by 2 over, or root 2 over root 2. So I get 2 root 2 on top over the 2's multiplied together gives me 2. There's a lot of 2's. And then my 2's cancel, so I get the root 2. Well, cosecant is that. Now secant is the reciprocal of cosine. So I flip that over, and it's the same thing all over again, so I can just go ahead and say it's root 2. Tangent of pi over 4 is 1 flipped over. Why do I want tangent? I don't want tangent. I want cotangent. So cotangent of pi over 4 is 1 flipped over. Number 48, they want us to find when the angle is just pi. All right. So yeah, we have to first locate it. It's at 180 degrees. My x value is -1. My y value is 0. So this is going to cause a few problems here. So we have the sine of pi. Sine is the y value. That's 0. Cosine of pi is the x value. That's -1.
Undefined.
Tangent of pi is going to be the y value over the x value. And 0 divided by anything is 0. So cosecant of pi, now this is going to be a little bit tricky because it was 0. So now when I flip it over, I get 1 over 0. And that is going to be undefined. Secant of pi is going to be -1 flipped over, which is still just -1. And cotangent flipped over is -1 over 0. Once again, if you divide by 0, it's undefined. All right, let's jump. All right, so now we're supposed to find, this is number 52, we're supposed to find the cosine of -13 pi over 3. So once again, we first have to identify where it is on the unit circle. So we're looking at pi over 3, so we split these into 3's. Too bad. And then we go backwards, counting. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I feel like I'm making a spider web. 13. All right, so here we are. All right, this is pi over 3, and I know it's kind of hard to tell because I did a bad picture, but it's kind of down here farther. So the x value is short, which makes it +1/2 then. The y value is long, so that'd be -3 over 2. So then the cosine is the x value, which is 1/2, so this equals 1/2. All that for one little answer. So you need to practice your 53 through 56 on this page. This is where you're using a calculator to find your answers, especially a problem like 53 and 54. Those ones are dealing with the fact that those are in radians and you're flipping things over. So you should practice those and make sure you get those ones right.
Did you just say you're splitting it into...
So next we'll work on number 58. I've got my triangle. We've got one side labeled 2, one side labeled 10, and we've got our angle right here. So our first job is to figure out what our third side is using Pythagorean theorem. So we'll have 2 squared plus our missing side squared equals 10 squared. So 4 plus x squared equals 100. get rid of the 4, x squared equals 96. Square root both sides, so we've got the square root of 96. Now, can that be simplified? The square root of 96. 96 is 2 times 48. Yes, I can simplify it, can't I? 48 is 16 times 3. So 96 is 16 times 6. So this is really 4 square roots of 6. So now, as I find, isn't that lovely? Okay. As I find my angles, well, let's just do it. Okay, so the sine of theta is the opposite 2 over the hypotenuse 10. You need to reduce that, people. 2 over 10 is 1/5. Also, I want to point out, on the test, you need to be able to do this. Okay? If you don't do that, I will mark it wrong. If this part right here, the square root business and simplifying it, okay? If we were in Algebra 1 or Algebra 2, I might be nice and not mark it wrong. We are in college trigonometry. We will do college level math. All right? I do expect it. Okay, now, which also means that instead of 2/10, you're going to reduce it to 1/5. Because that's like beneath us. Yeah. So cosine of theta then is adjacent 4 square roots of 6 over hypotenuse 10. And guess what? 4 and 10 can cancel, right? By the way, you'll never cancel with the square root of 6. Because it's not really a 6 in there. It is the square root of 6. So 2 goes in 4 twice. 2 goes into 10 5 times. So we get 2 square roots of 6 over 5. Now, I'll get to tangent later. Let's first do cosecant of theta. I'm going to take my answer 1/5 and I'm going to flip it over. I get 5 over 1. Secant of theta, I have to flip over that answer. You know what I'm going to do? Oh, here's a good hint to you. Secant, because typically what I could do is I could take this answer and flip it over, but then I'm going to have some rationalizing to do. I'm going to anyway, aren't I? Yeah, we'll just flip it over. What I was going to say is secant is hypotenuse over adjacent. Hypotenuse over adjacent. So then we could do that, but it'd actually be more work. So back to this. So we flip it over. We get 5 over 2 square roots of 6. So now we have to rationalize that. I wish I could move my paper, but I can't. So 5 over 2 square roots of 6. I'll work up here. So I got to rationalize it. Square root of 6, square root of 6. So we've got 5 square roots of 6 on top over 2 times 6 on bottom, right? Because square root of 6 times square root of 6 is 6. And 2 times 6 is 12. So I end up with, let me erase this. I end up with 5 square roots of 6 over 12. Now tangent of theta is the opposite 2 over hypotenuse 4 square root. I lied, didn't I? But I wrote the right thing. Tangent is opposite over adjacent. So 2 over 4 square roots of 6. The 2's cancel with the 4. And then I have to rationalize, because I can't have a square root of 6 on bottom. So I get the square root of 6 on top over 2 times 6 on bottom. Square root of 6 on top over 12. And cotangent, I'm really running out of room here. Okay, so cotangent, we'll put at the top, is instead of opposite over adjacent, is the adjacent over opposite. So it's 4 square roots of 6 over 2. 2 is into 4 twice, so we get 2 square roots of 6. Okay, we're going to jump now to number 70. So what's happening is they give us a point. We're supposed to graph that point, stop